The next topic is infinite series. Under that we study sequences and series. A sequence is a function from the set of natural numbers to the set of real numbers. The value of the function at the natural number n is called the nth term of the sequence and is denoted by un. The sequence itself is denoted by un inside flower brackets or un inside simple brackets. Given a sequence un, its formal sum, summation un as n tends to as n is equal to 1 to infinity, is called a series or infinite series. A series is also denoted by summation of un. Convergence and divergence of a series. The nth partial sum of an infinite series, summation ui as I is equal to 1 to infinity, is defined as Sn summation ui, which is equal to u1 plus u2 and so on up to un. The series summation ui is said to converge to the real number u if limit Sn as n tends to infinity exists and is equal to u. Then we say that the series is, that is summation ui, is convergent. If the series does not converge, then we say that it diverges or that it is divergent. So let's see a few examples. Consider the geometric series summation a into r power n minus 1, which is equal to a plus ar plus ar square and so on, where a is not equal to 0. We know that the nth partial sum of this series is equal to Sn, which is equal to a into 1 minus r power n divided by 1 minus r if r is not equal to 1. Now, if r is equal to 1, then Sn is equal to, that is here if the value of r is equal to 1, then Sn becomes a plus and so on. So Sn is equal to Na. Now, if modulus of r is less than 1, here in this series, if the common ratio modulus of r is less than 1, then r power n tends to 0 as n tends to infinity. Then limit of Sn as n tends to infinity will be equal to, since this term is equal to 0, limit of Sn as n tends to infinity will be nothing but a by 1 minus r, which is finite. If modulus of r is greater than 1, then r power n tends to infinity as n tends to infinity. Then limit Sn as n tends to infinity does not exist, because this term here becomes infinity. So limit of Sn as n tends to infinity does not exist. If r is equal to 1, then Sn is equal to a plus a, which is equal to Na. Now this value Na can tend to plus or minus infinity according to a greater than 0 or a less than 0. If a is greater than 0, it becomes plus infinity. If a is less than 0, it becomes minus infinity. So if r is equal to 1, then Sn is equal to Na tends to plus or minus infinity. If r is equal to minus 1, then limit Sn as n tends to infinity does not exist, since limit n tends to infinity minus 1 to the power n does not exist. Thus, this series, that is summation n from 1 to infinity a into r power n minus 1, converges if modulus of r is less than 1, and it diverges if modulus of r is greater than or equal to 1. For example, let's consider this series 1 plus 1 by 2 plus 1 by 2 square and so on. Now this here is a geometric series again with a equal to 1 and r is nothing but 1 by 2, which is less than 1. So now we have seen that if modulus of r is less than 1, r power n, which is 1 by 2 power n, tends to 0 as n tends to infinity. Then limit Sn as n tends to infinity is equal to a by 1 minus r, which is equal to 1 by, here r is 1 by 2, 1 minus 1 by 2, which is equal to 2. Now this here is a finite number, therefore we say that the series is convergent. Let's take one more example. Consider 1 plus 2 plus 2 square plus 2 cube and so on. It's again a geometric series with a equal to 1 and r equal to 2. Then Sn becomes a into 1 minus r power n divided by 1 minus r, which is equal to 2 power n minus 1. Now if you take the limit as n tends to infinity, limit Sn becomes infinity, hence the series is divergent. Positive series. A series summation un is said to be a positive term series or positive series if every un is greater than 0 for all n. That is, if all its terms are positive. A necessary condition for the convergence of a positive series is given by the following result. If summation un converges, then un tends to 0 as n tends to infinity. That is, if limit un is not equal to 0 as n tends to infinity, then summation un diverges. However, the converse of this statement is not true. Let's see a few examples. We know that the geometric series summation 1 by 2 power n is convergent. Observe that 1 by 2 power n tends to 0 as n tends to infinity. Consider one more example, summation un, which is equal to summation 1 plus 1 by n. Now un is equal to 1 plus 1 by n. As n tends to infinity, this term 1 by n tends to 0. So as n tends to infinity, un here becomes 1, which is not equal to 0 as n tends to infinity. Therefore, summation un is divergent. The harmonic series summation 1 by n is divergent. However, un equal to 1 by n tends to 0 as n tends to infinity. This shows that the converse is not true.